So thanks a lot, and good afternoon and good morning. So this is a sort of, I will say, high-level presentation from NextG Alliance on system view and architecture for 6G. The architecture is very high level, but I'll mostly talk about the system view. So these are the opening thoughts, which I think we are addressing, that these are the questions, 6 questions in our mind, that how will future 6G application impact my life? So that is the first question. Other question in our mind is, what is the 6G killer applications? The third question is, will 6G be evolutionary or revolutionary? The fourth question, what are the key industries that will benefit? The other question was, how will consumer benefit from 6G? And how will 6G connect to the metaverse? These are the 6 questions we are pondering about in 6G. We have done multiple white papers and research in these areas. So what is NextG Alliance journey towards 6G? So our goal is to develop a North American 6G vision with a collective set of research priorities. And then finally, we want to create a 6G public-private partnership for next frontier of innovation and investment. So if we'll go to the 6G library, we have at least 20 white papers, which anybody can download. So there is a 6G library for NextG Alliance, which I think is an important resource. With respect to application, with 6G, we want to change how we live. So some of the examples are, the first example is on eHealth, home-based patient care, remote surgery and scanning. The remote surgery is challenging. You can't do a surgery from one continent to other because of there is a limitation on that. The AI-enabled patient digital twin and assisted living. With respect to automotive industry, this is very important going forward. We'll have V2V and V2B safety improvement and awareness, automated, coordinated, and remote driving, although level 5 driving will not be a reality because of the regulatory issues for a long time, and real-time 360-degree situational awareness. On education area, we want to leverage EG innovation for education. We want to have metaverse experience, immersive knowledge and learning, and hologram receivers. And on the side of public safety, we'll have next generation mission critical communication. Of course, we'll have AR headset and glasses, networked robots and UAVs, and connected ambulances. And then the next thing, the 6G will change how we work. So look at industrial IoT, which will be, so we want to be the factories of the future, where we'll have AI managed automatic guided vehicles, massive sensor network to manage environment and resources. With respect to agriculture, this is an important area. We'll have movement between farming and road infrastructure, high precision irrigation and fertilizer treatment, and then massive sensing and remote actuation, communication across mobile and non-terrestrial networks. With respect to smart cities, extreme connectivity, use of digital twin replicas, high precision accuracy and tracking, urbanization, density, and access to resources, zero energy IoT devices. And some of these areas are already being researched in current release of 3GPP, AI-driven data decision-making, and government-provided playing fields for 6G innovation. So 6G will change how we live and how we work. Moving forward, in NextGA, we started around 2 years back with a set of 6 audacious goals. And the 6 audacious goals we are promoting, and I think it is universally accepted. And these are trust, security, and resilience. This is one of the audacious goals. Digital world experience, cost efficient solution, distributed cloud and communication system, AI native wireless solution, and sustainability. Now, with respect to each of these 6 audacious goals, which lays the foundation of NextGA, we have a detailed white paper on each of these areas. And these are the top priorities for North American contribution NextG leadership. Since it is a 20-minute presentation, I will just touch on these audacious goals and not explain to it, but you are all very aware of these goals. And in other parts of the regional alliances, these goals are there in some way, some form or other. Moving along, what we did, so you have the IMT usage scenario. So initially in IMT 2020, we have these 3 triangles, EMBB, MMTC, and URLLC. So this has been expanded to other 6 scenarios, which are immersive communication, integrated AI. It is AI and communication, so they removed the term integrated in the latest version. Hyper reliable, low latency communication, ubiquitous connectivity, massive communication, and integrated sensing. And the outer circle shows you have sustainability, which encompasses all these usage scenarios, connecting the unconnected, security and resilience. They removed the privacy part in the latest one, and ubiquitous intelligence. Now, needless to say that all these scenarios, all these use cases can be mapped into these 6 audacious goals, which is the foundation for NextG Alliance. In addition to the 3 which we have in 2020, IMT had 6, and then they have it is encompassed by this whole circle, which contains sustainability, connecting the unconnected, security and resilience, and ubiquitous intelligence. And this, as I said, can be mapped easily into the 6 audacious goals. We also have NextG Alliance, the top 10 research priorities. And this has been, so we have a research council, and they identified these are the 10 research priorities, which are security, trust, and resilience, new radio components and antennas, network convergence and integration, AI ML is very important. Spectrum sharing and enhanced spectrum access, very important. As the WRC 23, they have identified some of the bands for WRC 27, like 7 to 8.5 gigahertz, the 14 gigahertz band, upper 6 gigahertz band, and so on and so forth. And in US, in the 7 to 8.5 gigahertz band, it is a 1.5 gigahertz swath of spectrum, but there are a lot of incumbents in that spectrum. So this spectrum, instead of exclusive use, maybe it will be a shared spectrum. Of course, radio access technologies, joint communication and sensing is a very important area. There is a channel modeling work going on in 3GPP currently on integrated communication and sensing ICAS. Architecture and control of open disaggregated system. Sustainability is very important. Sustainability, reduced energy consumption and cost, and cloud native networks and distributed cloud. So these are the top 10 research priorities from NGS side. So one of the important things which I touched before is that what will 6G bring with respect to the verticals? So the verticals, although in like industrial IoT and stuff like that, didn't get much traction. although there are a lot of proof of concepts and test beds on verticals, but 6G should create value creation in this vertical. So we did a white paper on 6G roadmap for vertical industry, where we interviewed a lot of stakeholders in these vertical industries forum legs, and we honed in on 8 vertical industries like agriculture, which I touched before. This is how we change, we live and work. Automotive, education, gaming, and entertainment, very important. eHealth, industrial IoT, mining, public safety, and smart cities. And as we said, all these vertical industry implemented in the 6G era will change how we live and work, and we will translate North American needs to technology outcomes, target shared investments in 6G POCs and test beds, connect North American 6G need to marketplace. So this, I'll encourage you all to read this white paper, which outlines detail how these 8 verticals will impact 6G. The next, we have multiple work going on 6G enablers, technology enablers. And if you look at this, we 6G will contain both evolutionary and revolutionary technology. If you look at this evolutionary technology, which will have trustworthy communication, distributed computing, low latency, high reliable connectivity, peer-to-peer communication, trusted connectivity. With respect to revolutionary technologies, I will say work has already started on distributed sensing and communication. How can you use radar and integrate it with the communication technology, ultra 3D positioning, integrated AI, micro networks surrounding patient, very challenging. This is what we are looking at, that will have micro networks which will offload our current macro and other networks, so that we have a network focused around, say, for the automotive application within the vehicle or within the body, AI ML based situational awareness, and then innovation in capability and service offering, which will in facility and remote connectivity, coverage technologies for limitless connectivity. So this is important in the sense that in the USA, we want to provide complete coverage across the whole United States. And this is possible by combination of both terrestrial and non-terrestrial network. Trusted AI is very important, scalable latency, physical sensors, updating digital twins is very important. In summary, we have all these swaths of technology, which is both evolutionary and revolutionary, and that will be part of 6G. I'll touch only one of the audacious goals here because of the lack of time, which is distributed cloud and communication system, because this forum is related to the architecture. So 6G will provide distributed cloud and communication system where communications and unified computing services work together and scale across devices, network, computing resources, and data centers. So that is the overarching theme. The national imperatives will apply North America's expertise in cloud and software to shape the transformation to cloud-native mobile networks. And the research challenges are technologies to facilitate deployment of large-scale network, compute fabrics, innovation, integration, and interoperability of edge devices, automatic decision-making involving distributed and federated learning. Now, if you look at the right side of the figure, this illustrates the vision of the distributed cloud and communication system. The 6G cloud native design requires cross-discipline efforts, both from mobile communication and cloud computing communities. The following research directions are outlined. And as I said in this slide, 6G requires a mindset shift so that 6G is a system for both communication and distributed cloud computing. So what we identified, some of the research needed is how can computing services and data services be introduced into the 6G system alongside communication services? What is the right level of coupling between communication and computing? How can seamless computing and storage access be ensured using distributed nodes in the 6G system? How can the 6G wide area cloud incorporate both mobile device compute and network compute? How can the system leverage cloud computing technologies such as orchestration, microservices, and service mesh? So I'll leave you with the thoughts. We are doing research in all these areas, but I touched upon the main essence of distributed cloud and computing system white paper we published in next year. So finally, in the last slide, we think collaboration is key to the success. We have collaboration with a lot of regional entities with 6G SNS. Um, we have collaboration with Japan 5G, Beyond 5G Promotion Council, with Korea 6G, and also with Bharat 6G Alliance. And these white papers, which we have published, leads to, these are the foundational documents in our view, which lead to recommended priorities and action. I touched on what we have done so far in NextG Alliance. Uh, we have prioritized, we have this 10 research priorities, 10 research priorities for NGA. We want to increase the velocity of 6G research and collaboration across the ecosystem. And we are a believer that the 6G leadership requires collaboration across government, industry, and academia, which we are just doing. I will give you an example that we recently launched the Joint Communication and Sensing Channel Measurement Initiative, where we have government, academia, government entities like NIST, National Institute of Standards, academia, various universities in North America, and industry participating in making this channel measurement for joint communication and sensing. With that, this is my last slide, and thank you for the opportunity to present. Thank you. Hope I made within 20 minutes.